in this chapter of optics, we have already learned, in fact we would have also learned in smaller classes, but it is quite possible. In this class itself we have learned about the reflection of light by a plane shining surface, or which can be generally called as a plane mirror, isn't it? So, a mirror, if I shade it like this, that is the polished, non-polished side. Okay. So, that is the polished side. So, naturally if this is going to be the polished side, then light will fall on that and then only it will get reflected. So, the imaginary line perpendicular to the mirror is known as normal. We have a beam of light. There are so many beams of light which will come from a object. We are just considering for one. So, what applies for one beam is applicable for all type of rays. Okay. So, this ray, it hits at this point, say O, on the plane surface. This is incident ray known as IR. Whenever you draw the ray diagram, the word itself says ray diagram, the word is ray. That means this symbol is essential. If you draw the entire diagram without this arrow mark, it has no meaning. This shows that the ray is coming like this, this arrow shows. Once it starts coming like this, obviously it is making an angle I with the normal. This angle is known as angle of incidence. All these things we have learned, just a small revision. Then it is reflected back, reflected ray, again arrow is essential. You get an angle of reflection. This is angle of reflection, this is angle of incidence. The angle between the normal and the incident ray, angle of incidence. Angle between the normal and the reflected ray, angle of reflection. Already we have learned I is equal to R. Always the angle of incidence is equal to angle of reflection for a plane mirror. This is known as a plane mirror because the surface is flat. Also another law which says that this ray, incident ray, normal and reflected ray, they all lie in the same plane. So, those are the two laws, the most important one being I is equal to R. Using this plane mirror, we have also learnt how do we find the image of any object. Suppose this is the plane mirror here and you are standing here in front of that at a distance, say this is the person AB is standing like this. What happens? From this point B, there are so many rays coming out from the entire body, but we do not have to consider all this thing. We will just find the reflection of the point B, that will give us where the point A lies. So, how does it go? From here you have angle of incidence. These lines when you draw in your notebook, please use a scale to draw. There is no such thing as freehand drawing in optics. Okay. So, this is angle of incidence. So, naturally it will be reflected here. So, this is angle of reflection. So, if I am standing here, the eye is here, if I look at this, I believe that it seems to come from this ray is actually appears to me that it is coming from this point P, or you can say that point as B dash, such that this distance and this distance are same, which means B dash is the reflection of the point B. That gives, if this is say point R, then RB is equal to RB dash. This length and this length are equal. So, B dash is the reflection of the point B. From here when I see, it appears to me that the light from B is not coming like this, but actually it is coming from B dash. So, it is appearing to be coming from here, it is not really coming, really the light is coming from here, but when I see from here, to me it appears that the light is coming from here, hence image of B is B dash. If I extend this with the same thing, I can write this as A dash. So, AB is the object, A dash B dash is the image. Look at the nature. The nature is that this is also standing erect, that is straight. This is also straight. When we stand in front of a mirror, we do not see ourselves upside down, we see ourselves straight. The way we are standing, exactly the same way we see ourselves in the mirror, except for one small change. What do we see? What we consider as a right hand here, if you move your right hand in the image, it appears that the image's left hand is being moved. So, that is what is known as a lateral inversion. But apart from that, if this is erect, this is also erect. This image B dash A dash of the object BA is not a real image, but it is called a virtual image because it appears to come from here. It is not really coming from this point. So, this image B dash A dash is the virtual image of the real object, which is ourselves. We are standing in front of a mirror. We are real. The image is not real. It is only virtual. A virtual image is always erect. Our image, we always, when you look at ourselves in a plane mirror, we see ourselves erect only. We have never seen ourselves upside down. So, a virtual image is always erect, and erect image is always virtual. So, that is the speciality of the plane mirror. Apart from that, the size of the object is the same as the size of the image. What you are here, the same thing you will appear to be there. If you are 4 feet tall, your height there also will be 4 feet tall. If the pen is say 6 inches, there also it is going to be only 6 inches. Another point, RB and RB dash are same length. That means, if you are standing 5 feet away from the mirror, plane mirror, the image behind the mirror is also only 5 feet. These two distances are same. So, these are the 3 important properties of the image of a plane mirror. It is virtual and erect. It is of the same size as that of object. It is only laterally inverted. The fourth one is, it is as far behind the mirror as it is in front of the mirror. The object, whatever the distance here between the object and the plane mirror, the same distance is there between the image and the plane mirror. So, these are the 4 very, very important points of a plane mirror reflection. So, this is a reflection by a plane mirror. This is the plane mirror.